A quick word on the normal distribution. As we know, the normal distribution occurs in nature a lot. It occurs in probability theory, and it is all over the place in statistics. So we talked about the 68, 95, 99, 7 rule, which tells me if I have a normal distribution and I count out one standard deviation from the mean each direction, within these dotted lines falls 68% of the data. In other words, if that curve has an area of 1 or 100% of the data is there, 68% of the data falls in here within those one standard deviation bars. Likewise, if I count out two standard deviations, I cover 95% of the data, and within three standard deviations is 99.7. So we have the 68, 95, 99.7 rule. And I'll do this one down here. Now, from that, I can figure out several different things. So, for example, if I know that within those two red lines are 68% of the data, then I know that 34% must be here. Let me do this in a different color. 34% must be here, and 34% must be here. Likewise, if 95% of the data is within those green lines, 95% divided by 2 is 47.5. So this distance is 47.5%. Well, I've already got 34% of it right there, so this must be 13.5%. And likewise, you can do that with the next standard deviation, and that would tell me if 99.7% was within three standard deviations, 0.3% is outside, which means that 0.0015 is down here and 0.0015 is here, and you can kind of figure out those different dimensions. Now, the 68, 95, 99, 7 rule is great. It's very handy. It's easy to use and to estimate without a calculator, but it's all predicated on having a normal curve. So if the curve is not normal, this doesn't work. So how do I know if the curve is normal? Okay, well, there's a couple of different ways that I can figure it out. First, the problem says it. This is a great idea and worth circling as you read through the problem. If the problem states it, it's normal. Another way, I graphed it. And we could look at the graph and decide it's close enough to be normal. Doesn't mean it is normal. We ought to say approximately or roughly, but you might graph it and actually decide, or the sample size is large enough, maybe more than 40, at least 10 successes and failures. It wasn't too bad to begin with, so I didn't need as big of a sample size, but the sample size is large enough for the sampling distribution, remember a distribution of samples, to be pretty darn close to normal. Those are three ways to help figure out if a curve is normal, and if it is, then the z-table works, or the 68, 95, 99, 7 rule is applicable.